Hello, welcome to another briefing. I usually do one of these every week. However, occasionally I will decide to do an update if I feel like conditions have changed enough that the forecast or the commentary warrants an update because either because we have a forecast for more rain than we did, or significantly less rain than we did, or more cooling than we did, or more heating than we did, anything like that. And what I'm seeing in the computer models for the latest projections, particularly for the west coast of the US, is I'm seeing a bit more cooling down into California for this weekend than was forecasted originally. And I'm also seeing a bit more rain, quite a bit more rain for the Pacific Northwest than was originally forecasted. And this is a lot of quite significant relevance for August, when you get any kind of rain on the West Coast or in the Pacific Northwest, even in August. Even the Pacific Northwest is not very, does not tend to get a lot of rain in August. So this is something to watch for sure. So the first thing I wanted to talk about is this incoming cool down and the rain. But I wanted to talk a little bit about how this is also really suppressing those typical afternoon thunderstorms that we have over the Rockies. And the reason that is happening is because we have a lot more of a drier flow up in the upper levels of the atmosphere. We have a more of a west wind direction. If I put this in a different map here, you can see the wind barbs, and you can see that the wind is blowing predominantly from the west instead of the south. See, usually when you have those afternoon storms pop up over the Rockies, you have winds out of the south. Because I'm just going to show you the projection for storms where it might rain over this afternoon, and you see usually you have rain where I have the mouse now. You have rain all throughout this region here, especially Colorado, the Rockies, Utah, Arizona, parts of Nevada and Idaho sometimes. And there's absolutely no activity forecasted for this afternoon over these areas, because it's not only will it be under a big dome of high pressure in this particular area in the Four Corners, where the air sinks and warms and it's harder to get storms to form, but that subtropical moisture tap is not going to be there. Because usually when you have, I'm just going to put this in a bit of a wider view, when you have that subtropical moisture tap, you have the winds out of the south, which are favoring that. And you can see with this projection, with this troughing carving into the west coast, which will be related to the cooling and the Pacific rain that I'm going to talk about later, which is different than the subtropical storms. It's important to point out because some people might get confused, because I said in my last video that troughing kicks out the subtropical rains, and sometimes for some areas it can make it drier. But it's important to distinguish. It makes it drier in terms of it for areas in the Intermountain West. It makes it drier because it pushes the subtropical moisture out of the way, and any moisture from the Pacific that might come with these with this system, it dries out, because once the air, this is a west wind, and the air goes down up and over the Sierra Nevada mountains and upper and over the Wasatch Mountains and these mountain ranges in Nevada, the Ruby Mountains and such. And when the air goes over them on the easterly side, it sinks and warms, and the sinking air is also something that makes it difficult for clouds to form. So because of that, and because this isn't a very strong, massive winter storm, it's not going to have enough lift to bring any Pacific moisture over the mountains here. And at the same time, it's inhibiting that subtropical moisture. So if I put this into motion here, you can see at that trough having that effect. And then you can see there might be a chance, I'm going to get to this later, but there might be a chance of rain in a few days, because then the winds are shifting more south, and then you might have that subtropical moisture tap once again. So it's I just wanted to explain a little bit about how that works in case there was confusion around that. But it's important to remember the subtropical moisture that causes the afternoon storms over the Rockies come from a different dynamic than Pacific storms over that bring rain to the Pacific Northwest, the coastal areas, which will be associated with this other weather system, which I'm going to now talk about in more detail. So, now to the weather system that I was just mentioning. This cold upper level low that's going to carve out over the Pacific Northwest in the next few days. So you can see, if I put this in the height anomaly map, which you're going to see the pressure anomaly at 18,000 feet, not just the pressure at 18,000 feet, but the pressure anomaly. You see this deep pocket of well below average pressure, which is associated with that cold low, down to 567 decameters, which is pretty low for this time of year. That's pretty significant. Usually the rain line, from what I've heard from other meteorologists, for the Pacific Northwest, when it's in between 570 to 573 is when you have enough lift to usually generate rain showers. And you see that 573 line, it's going to be going well into Oregon and Washington as I put this into motion. You see that it definitely, heights definitely seem to drop enough to warrant rain. And you also see that as we go into the weekend, as we go into Sunday at 5 p.m. here on this frame, you can tell there's likely a southerly wind here, because you look at the ISO lines, and you usually, if you have a low pressure, because the winds go counterclockwise around low pressure systems in the northern hemisphere and clockwise around high pressure, usually you have a low pressure here on the left side and a high pressure on the right side. And if it's low pressure in the northwest and high pressure in the southwest, you're going to have a pretty significant southwesterly flow. If I put this in a different map, you can clearly see that southwest wind flow. I didn't even have to look at that map to know that it was going to be a southwest wind flow, because of the positioning of those pressure systems. And sure enough, I look at the wind projection, and that's exactly what's being projected. These are pretty strong winds too. And this can actually bring a subtropical moisture tap, as I was mentioning earlier, to mountain areas. And this is definitely enough to bring Pacific moisture advecting over the coastal hills and a cold Pacific system into Washington and Oregon particularly is where we're expecting to see rain from this. See, this is the projection for rain by 5 p.m. Sunday. You're looking at over a half an inch in Seattle. I believe the last video I did a few days ago was maybe a third of an inch being projected, and this is over a half an inch on the national blend of models, which is a blend of all the computer model projections out there, so it tends to be pretty reliable. And this is pretty short term. This is just 3 days from now, and so I would say pretty high confidence, in my opinion, or at least increasing confidence, that we will have potentially over a half an inch of rain for Seattle, which is significant for August. Portland would be looking at probably 3/10 to 4/10 of an inch, still significant as well. Looking at 3/10 of an inch here in what I believe is Salem. And looks like down the Willamette Valley all the way into parts of Northern California. Parts of Northern California could have over 1/10 of an inch. So this would be really significant, and this would be resulting mainly from that cold low over the Pacific. So this would be a cold Pacific system, or at least a cool system, cold for August standards, perhaps. It's not a super cold winter storm, of course, but it's cold for this time of year. And then here, when you see this rain over the Four Corners area, you see it primarily over Arizona and Utah here, going into parts of Idaho and Montana. That is a different kind of rain. That is a subtropical moisture induced. Those are subtropical moisture induced thunderstorms that is causing this rain. And then you have a dry shadow here in most of California and Nevada and parts of eastern Oregon, eastern Washington, and southwestern Idaho. And that is because it is right in between that subtropical moisture flow and the heating over the mountains, which brings the thunderstorms. There are not enough dynamics for that kind of rain, and it's also just a little too far south to benefit from any dynamics from the cold Pacific storm. So it's kind of in this little dry sandwich. California and Nevada are mostly in the dry sandwich here, in between the cold, wet system in the Pacific Northwest and the subtropical moisture-induced storms in the inner Mountain West. So that's pretty much mostly what I wanted to talk about. I just wanted to give a brief overview of temperatures, because that's the other big thing that is changing a little bit. It's looking a little bit colder. This is the temperature projection in Celsius at 5,000 feet, and I'll translate this down to the surface. But basically, I just wanted to show you this pocket of cooler air. I'm actually going to show the anomaly, because that'll just give you a good idea of this below average cold air that's going to be coming in. This is at the 5,000 foot level, but of course it mixes down to the surface eventually. And the reason we like to look, meteorologists like to look at the 5,000 foot level a lot, it is because you get a better picture of the temperatures without the influence of the surface. Because a lot of times if you look at the surface temperatures, because of the terrain features on daytime heating and nighttime cooling, you have a lot of fluctuation. And if you look at 5,000 feet, you have less fluctuation, so it gives you more of a big picture of what the temperature and the temperature anomaly is doing. And so here you have this significant push of cooler air. It's looking even a little bit stronger than previous model runs. It's looking like it's going to come more into California than it was before, and that is going to translate to cooler temperatures, cooler high temperatures forecast. So this is the projection for Saturday the 17th for maximum temperatures in the Bay Area. And you can see a lot of the inland valleys that for this particular day, a few days ago were forecast to be in the mid 80s, are actually down to the low 80s. Some locations barely hitting 80 degrees. The warmest inland locations of the Bay Area barely reaching 80, only 81 in Livermore. You have 79 in Novato, 74 Petaluma, 79 Santa Rosa, 78 in Healdsburg. Both Santa Rosa and Healdsburg not hitting 80 degrees. These locations just not long ago, just a few weeks ago, were baking in the 100s day after day. So this is much, much cooler than it has been. This is probably going to be some of the coolest air that we've had in weeks over the Bay Area. This projection is actually looking for some areas even several degrees cooler than it was a few days ago. Like, for example, from Healdsburg down to Novato in the North Bay, we were looking at these temperatures mostly in the low 80s being projected for Saturday the 17th, and now the projection is calling for 70s. So we're seeing only 87 in Sacramento. A lot of the Central Valley not getting to 90 degrees, where they had been in well into the hundreds for most of July and even a lot of August. A lot of 100-degree days there. I think I heard something like over 30 days above 100 degrees in downtown Sacramento already this summer. So 87 degrees, that's going to be very comfortable. Average is about 94 for this area this time of year. So 87, that's well below average, and that's going to feel very comfortable for the Central Valley that has been baking in the hundreds, even occasionally some days up over 110 in early July. So, much cooler air on its way, looking even a little cooler than originally forecast, because it looks like that big low pressure system is going to drop even a little further south than originally forecast, as you can see here on the heights map and on the temperature anomaly map. That's all I have for this update. Thank you for watching. I hope you were able to get something out of this, and I'll see you next time.